We all set on the? Okay, great. Hello, everyone. Welcome. Sorry about the little delay. My name is Daniel Roth. I'm a program manager on the ASP.NET team. And this session is about building services for virtually any client using ASP.NET Web API. Now, why might you want to build Web APIs? Well, today there are more client platforms available to you than ever before. And they're all interesting, and you want to get your apps available on those platforms. There's multiple browsers. There's phones, there's tablets, there's slates, there's gaming consoles, there's set-top boxes, and all sorts of interesting hardware. How can you get your app to be available on all those platforms with the same back-end logic? Also, with all this opportunity to hit more clients and more users, scale is more important than ever before. With the rise of the cloud and cloud services like Azure, you have access to a highly scalable infrastructure, but in order to really take advantage of any scalable infrastructure, you still need a scalable architecture. So how can you do that? Well, using Web APIs can solve both of those problems. First of all, because HTTP as a protocol is ubiquitous. All these client platforms can speak HTTP. So if you make your back-end logic, your data, your business logic available over HTTP, all these client platforms can access it. And HTTP also has a great reputation for scale because that's the way the web works. So the idea here is to leverage the web when building your services by building Web APIs. So what is a Web API? It is just an HTTP service. It's a vanilla HTTP service. Very little layered on top. It's a service that's intended for broad reach. You're trying to hit as many client platforms as possible. You want it to be broadly consumable. And typically, it's an HTTP service where you actually want to use HTTP as it was intended, as an application-level protocol, and not as just a transport for shoveling bits around. So you want to take advantage of the semantics of the protocol, like caching and headers and formats and so forth. So ASP.NET Web API is a relatively new framework that's designed and intended to help you build these kind of HTTP services or Web APIs that can reach a broad range of clients from browsers to mobile devices. I thought it would be useful to show an example of an application that has these characteristics. And so I've actually got some friends here from the Microsoft Link Server team that have been hard at work and were kind enough to show up on stage to show a demo. Microsoft Link Server in Microsoft Office 2013 has a need to be able to hit a variety of clients to enable real-time web-based communications. And they do that through this new web API called the Unified Communications Web API. And it's built on top of ASP.NET Web API. So if you're using any of these available clients for Link 2013, you are actually using ASP.NET Web API in the back end through UCWA, it's what we call it for short, UCWA, Unified Communications Web API. And so it enables experiences ranging from rich HTML5 experiences through the Link web app, all the way down to a variety of native client app experiences like Windows Phone, even iOS, and Android. And so we thought we would show you a little bit of what this looks like and what experiences ASP.NET Web API can enable. So let me switch over here, and let's take a look at Link on Windows Phone 8. I'd like to introduce Alex and Stefan, Alex Edelberg and Stefan Tane from Microsoft Link Server. Cool. So great. Alex, this looks like a Windows Phone 8 device, and you've got Link loaded up here. Can you tell us a little bit about what this thing is capable of and how it's using ASP.NET Web API?
Yep. Thank you very much, Daniel. So as Daniel said, Alex and Stefan from the Link Server platform team. And we have here a preview of Link client for Windows Phone 8. So it's a preview client on a preview device talking to a preview server. So let's all pray to the demo gods for a second here. We are going to do an IM session for you guys. So as you can see, we're looking at the phone. There's my hand live. Go ahead and send an IM to the phone. Oh, Stefan, you switched to. 1 second. Demo gods are getting their revenge already. Let's try it again.
Don't disturb Stefan. He's a busy guy. He's got lots to do.
Okay, we'll go the other way. So there we go.
You look an awful lot like me, Alex, in this demo.
There we go. I came back. I'm still sending.
So are these IM chats actually going through UCWA? Are they going through ASP.NET Web API? Is that what's happening here?
That's what's supposed to be happening, yeah. Let's give it one more shot here.
Had a little issues with the wireless connectivity.
Yeah, it looks like we do have an issue.
It's preview. Let me.
Yeah, you get to see the whole thing from the beginning.
Want the image stabilize a little bit, a little whitewash. There we go.
Yeah, we're waiting for the client to sign back in. The connectivity's a little bad. If anyone's live streaming this, can you hold up for a second? Okay, well, it looks like we might not be able to show that phone demo today, so.
Okay, so the IM chat works on the phone. What is it, like, is it, I can do voice, I presume, over the phone?
Yeah, we're going to show off IM, voice, video.
Full video conferencing over a phone device through the up-and-coming Link 2013 for Windows Phone 8. Okay. So I'm having some issues with this client, but maybe there's some other clients we could show. Yeah. Or you want to try?
Yeah, let's go ahead.
Let's go ahead. So, how about we show the web client?
Yeah, let's go for it.
That one's a little bit more not in preview. So I've actually, this whole feed that you're seeing right here is being done through the Link web client. If I pop out here, you can see this is actually all in the browser. So this is real streaming video coming through the browser. Let me switch out of full screen mode, and I'll switch to be just a participant in the meeting here. So there's Alex, and you can see his video. So I can see video from Alex. I see video from Stefan's camera. That's awesome. What else can we see here? So I have a control over my voice settings, like whether or not I'm muted or not. I have control of whether or not I'm sharing my video. I don't know. Can I start my video, Alex, or you currently signed it as me? That's probably maybe not a good idea. I won't try to do that. I can share my desktop through the client. Yep. I can also I can see who's joined the meeting through the roster. Again, we have client. Let's see some client. There's some.
So here now we're looking at my desktop, and this is actual screen sharing.
Yeah, so Alex is now sharing content with me. So how much of this is going through? Is it just a few things here and there that are going through Web API?
So the signaling happens via the Web API, and the media is actually sent peer-to-peer. So when I offered to share my screen with Daniel, it went up through the Web API, through the WCF and the layers that we wrote, came back down to the browser, and his client said, Alex is extending you a media offer, and then we have a plugin today that will engage in the media sharing. So once the negotiation happens through our API, the bits representing the actual screen sharing image will go back and forth directly.
So pretty much everything except for the media is actually being done just with HTTP and through UCWA, through ASP.NET Web API.
Exactly.
That's awesome. So what are you showing here? Like this looks like the document, some Web API documentation. Is UCWA intended for third-party developers to also be able to consume?
Exactly. This will be released along with the phone clients in the coming months, and it will be a fully public API that we'd expect developers to work with. And using the ASP.NET Web API framework, we've built a very standard and easy to navigate REST-style API. You can see we support both JSON and XML formats. If I go down to the payload, it's in JSON format. Quickly switch it to XML. It'll show you a sample in XML instead. You can see standard HTTP verbs. In this case, this resource can support get and delete. And our API is hypermedia driven, and we found that a really great way to educate developers is to actually show them the graph that they need to navigate. So this API, we can see, allows different forms of communication, messaging, online meeting, phone audio. And actually going ahead and sending an IM is as easy as navigating this graph of links. So I go to communication, start messaging, go to a messaging invitation, and that would start the IM conversation that we were attempting to show over the phone.
So these are links that are sent in, like responses to the client. The client can then pull out and use in order to navigate the state of the Web API. That's great, and this is fantastic documentation on how to do that. Wow. Okay. Cool. So hey, thanks guys for showing us what's available and what's possible.
Hey Daniel, let's switch back to that video feed. It looks like the phone's finally cooperating.
Oh. How do I do that?
Here,
how do I hide your stage?
I'll stop. Yeah, sharing my screen. That'll do it. There you go. So there we go. Actual IM being sent in real time.
I am being sent in real time to the phone. Awesome.
What the video is doing.
So that's phone, web. This is Windows Phone. It's also available on iOS, available on Android. Link web app in the browser. All these clients are being made available. Oh, here we got a video.
Oh, it's thinking about it at least. Oh, no.
Nice your video.
Yeah, it didn't
The
go.
webcam was not on.
Yeah, my webcam's not hooked up. Let's try this one more time.
Let me.
Demigods, please, let there be video.
Go ahead.
Okay, new toast.
So you saw my M
No.
shot that showed up on that client.
No, I think the client's.
That's right.
Yeah,
I think they get the point. I think they get the point. What's possible. This is in preview. Thank you guys for taking this opportunity to come and show us this stuff. I know this is early bits. It's great to see it. Very cool. All right. So what do you get out of ASP.NET Web API? How does it help you enable these kinds of rich experiences for all of your clients? Well, first and foremost, it gives you a great first-class modern HTTP programming model. This is the new HTTP programming model that is also available in client, the new HTTP client that was shipped with .NET 4.5. It's strongly typed. It's fully async. It's just a delight to work with. If you haven't worked with it yet, please do. I think you'll find that you'll never want to write another line of HTTP web request code again. It's just fantastic. We also make it available to you on .NET 4 through ASP.NET Web API. That's a separate download. It's not in the framework, but you can still get a .NET 4 build of the HTTP client. And we take that programming model for HTTP and we use it symmetrically on the server. So you have a symmetric HTTP programming model on client and server with ASP.NET Web API. And it's right there at your fingertips. It's not hidden underneath layers of abstraction. If you want to deal with headers, status codes, any part of the request to response message, you have that available to you. ASP.NET Web API makes it really easy to implement the standard, the uniform interface for your HTTP resources. Get, post, put, delete. HTTP has well-defined semantics for these actions, and it's really easy to implement those actions with ASP.NET Web API. You need to give your resources also an identity so you can send those requests to them, and ASP.NET Web API allows you to use full ASP.NET routing in order to assign URIs to your resources. HTTP is all about formats. Like any request response could have a variety of potential media types. They could be binary, they could be text, PDFs, images. ASP.NET Web API makes it really easy to deal with any format, including your own custom ones. And you can plug them right into a full and rich implementation of HTTP content negotiation. What that means is when a client asks for a particular format using the standard HTTP way, saying, I accept these formats, do you have one? ASP.NET Web API will take care of handling that request and picking the right formatter and formatting out the response for you. Like we just saw with UCWA, with the Microsoft Link Server, ASP.NET Web API allows you to write hypermedia-based web APIs. These are linked web APIs. It's the way the web works. Instead of knowing the address of every single resource, you just follow links as you discover them through the web API. You can easily generate links using ASP.NET Web API. It's very easy to separate out cross-cutting concerns. Like there's a lot of things when you're dealing with HTTP that you'd ideally like to not pollute your business logic with, like dealing with authorization, dealing with query, dealing with various aspects of HTTP like caching and e-tags and so forth. It's very easy to pull those things out and stick them into the pipeline in a cross-cutting way. There's a very flexible hosting model. You can host your web APIs, of course, in IIS and in ASP.NET. We think a large part of people will be doing that. But you can also take your web APIs and host them in your own process. You can self-host them in a process. You can host them easily on Azure. Publishing to Azure is a cinch. And lastly, we wanted the whole framework, we designed the whole framework to be lightweight, to be really easy to configure, to be testable, and to scale really well. The whole framework, top to bottom, is fully async, and it uses the new task-based async programming model. So you can take advantage of the await and async keywords in C# and get the benefit of making efficient use of your server resources. So how can you get started with ASP.NET Web API? Well, if you have MVC4 or you have Visual Studio 2012, you've already got it. ASP.NET Web API is a relatively new framework. It's shipped with MVC4, so it's in the box with MVC4. It doesn't have a technical dependency on the MVC4, like the MVC bits. It doesn't have a system web MVC dependency. But that's the ship vehicle. That's how you get the bits. It's also available as standalone NuGet packages. If you're not familiar with NuGet, NuGet is a really great package management solution where you can easily create a new web application project with nothing in it, go to NuGet, grab some packages, have them installed in your project, and you're up and running. It's supported on .NET 4 or later, as I mentioned, and you can find our documentation on the ASP.NET site. I also highly recommend that you try out the just recently announced and released ASP.NET Fall 2012 update preview. Will add a bunch of new template features, a bunch of new functionality on top of what you got with MVC4. Adds some great features for Web API, help page, OData, tracing. Encourage you to try those out. That's how you'll get the latest stuff. So let's create a Web API. Let's create our first Web API. So what I'm going to do is I've got Visual Studio 2012 already installed on my machine. I'm going to go ahead and do File, New Project. And I'm going to create a web application. Let's create a new MVC4 web application. Let's call it My First Web API. Now, I don't have to start with an MVC project. I could start with a web forms project. I could start with like a web pages project. It works in any of those projects. You can mix and match. There's some nice tooling that comes with the MVC project template, so that's why I'm starting here. I'll click OK. All right, great. So this is going to bring up the new MVC4 project wizard. You notice I have a nice Web API project template that I can pick from. I have the option of creating a companion test project along with the Web API, so I can easily test my Web API controllers. I'm not going to do that right now, but you can certainly do that. And now what's happening is actually the project is being set up with a bunch of NuGet packages, the Web API ones and some of the new preview ones, since I do have the ASP.NET Fall 2012 update installed. And this is going to give me a bunch of stuff that's going to allow me to get up and running really fast, except for the delay in actually installing the NuGet packages. But as soon as it's done. All right, cool. All right, so now what did I get? So you'll notice that I was given a sample API controller. If you're familiar with MVC, you'll notice that this is not a controller, like Big C controller. This is an API controller. It is a controller, and it follows a lot of the same patterns and practices that you might be familiar with when working with MVC. But it has some differences, because the idea here is not to serve up UI and HTML, but to actually create a service. And we've optimized the dispatcher and the programming model around that scenario. So you derive from an API controller. This is a simple values controller. It just serves up some static data. Let me collapse the definition so you can see what's here. You'll notice that the action methods on this values controller map directly to HTTP methods. There's a get action, there's a post action, there's a put action, delete. These are just the normal unified interface of HTTP. So it's really easy to implement that uniform interface with Web API because you just define methods with those names. We follow a simple convention that if the name of the method is prefixed with the name of an HTTP method, like get, post, put, delete, then we'll assume that that action is meant for that HTTP method. So this get method will respond to get requests. This post method will respond to post requests. If I don't like that convention, that's fine. Like let's say I wanted to call my put action update or something like that. Then you just need to tell us which method you want that method, which HTTP method you want that action to handle. All right, cool. So that's a key difference between Web API and MVC. Is in MVC, your actions are kind of these strings that show up in the URI. It's more of a remote procedural call pattern, honestly. But in Web API, your actions literally are the HTTP methods, the HTTP verbs. All right, so where is this thing located? How did I assign an identity to my values controller, my values resource? That's done in the configuration. It's done through routing. So here is my Web API config, and there's this HTTP configuration object, and that has all the configuration data for my Web API. And you notice I'm just adding a route. This is the default Web API route. It looks a little bit different than the MVC one. It's API. We added an API prefix, so it has a separate namespace from the MVC set of routes. But it's controller. That should look familiar. There's a controller route variable, and then just ID. There's no action. So like I said, your actions are the HTTP methods. If you wanted to add a route that has a curly brace action route variable in it, and you want to dispatch based off of that string, that will work. We support it. but we recommend probably shouldn't mix and match them. They don't mix particularly well. Either go HTTP or go action-based dispatch, but don't try and do both at the same time. It doesn't quite work. But in general, as you can see, we tried to encourage you to use HTTP as it was intended. Use it in a resource-centric way. That's why you don't see any action variable. So we'll take this controller variable. We'll find the controller. So that means if I run this, let's take a look at what this web API actually looks like. Okay, so this is just some template HTML. You'll notice there's this API link in the upper right-hand corner of this page. I'm going to click that. And this is an automatically generated help page that we provide for you in this project template. This help page looks at your web APIs, finds all the API controllers, looks what actions they expose, looks at your routes, and figures out what the URI space for this web API looks like. So you'll notice I have a values controller, and the addresses for this values controller are API/values. I can ask for all the values. I can ask for individual ones by ID. I can post new values and delete values. If I click on one of these things, I get further documentation about the particular HTTP endpoint. We'll pull documentation directly from the dev comments in the code. That's kind of nice. And then I can see example request and response formats for the messages that this web API supports. You'll notice that this web API, out of the box, just by hitting F5, it already supports JSON and XML. And it's showing me example payloads of what those things look like. Okay? Now, let's see if that actually works. Let's make a call to the web API. So API/values. I'm going to do this first in IE. And IE is basically doesn't send an accept header that's interesting to web API. It doesn't say XML. It doesn't say JSON. So in this case, I'm just getting the default format from the web API, which in this case happens to be JSON. So there you see value 1, value 2. Let's try it in Chrome. Copy the address. Now, in the case of Chrome, they do send an accept header. The client, in this case the browser, is saying, hey, if you got HTML, I'd prefer that, but if you also have XML, that's OK too. Otherwise, just give me what you got. So because it's asking for XML, web API is smart and says, oh, you would prefer XML. Let me give that to you instead. So in the case of IE, you got JSON because it didn't say otherwise. In the case of Chrome, you're getting XML because it actually asked for XML. Okay, so that's content negotiation in action. All right, so I made some web API calls. If I look at the output window, let's see here. You'll notice there's a bunch of interesting information showing up here in the output window because we've enabled web API tracing by default in the project template. We've basically wrapped every part of the web API system, and we're tracing each of the key points in that system, and it just shows right up in the output window because we're using system diagnostics in order to do that. So if you look at these traces, you notice I can see, oh, there was a GET request, and it was sent to API/values. And then I get a whole bunch of information about what formatter was picked. So like in this case, it's saying I'm going to use the JSON media type formatter. So that was the IE request. So this is really convenient when you're debugging your web APIs. This is new in the fall 2012 update of ASP.NET. You have tracing also enabled by default in your projects. Okay? So that's your first web API. It's pretty simple. So in order to create a web API, first thing you're going to want to do is you define your routes. You define your URI space. We provide a route for you. That should work for a lot of cases, but you may need to add more depending on how complicated your scenario is. And then you create a new class that derives from API controller. You name your class whatever you want that controller variable to be when it shows up in the URI, and then controller at the end. So values controller will show up at API/values. Hello controller will show up at API/hello. And then you implement your actions. And so what I'm going to do is I'm going to walk through how web API deals with the request as it arrives at that controller, how we pick it, how we deal with the actions. So we just talked about you're going to route to your controller using routing. We provide a default route for you. We'll look at the route variable and go find your controller type based off of that route variable in the route data. And then next, we're going to pick an action on that type. So how do we do that? Well, like I said when I was showing you the code, Web API actions map to HTTP methods. You prefix your action name with the HTTP method that you want to handle. Like get customer would be a get request. Post comment would be a post request. Delete orders would be a delete request. You can override that naming convention if you'd like using the attributes, the HTTP get, post, put, delete family of attributes. And we do support some overloading semantics. Like if you have two actions that are both handling get requests, well, which ones should you handle? Well, the way we do that is we look at the data that's being passed to the action, the parameters that it's asking for, and we look at the data that's coming from the URI. And the action that's taking the most data from the URI, we assume that's the better action to call. We look at the required parameters, and if you satisfy the required parameters, then we'll call that action instead of the other one. So in this case, where you have like two get actions, where one of them is taking an ID, if an ID happens to show up in the query string or happens to show up in the route data, we'll prefer the get action that takes an ID. Otherwise, you'll just get the get action that doesn't take anything. Does that make sense? So you can do some sort of merging of your resource model on a single controller. But in general, the model is basically that you have a controller per resource. And like I said, action-based dispatch does work. We do have the ability to look at the action variable and just pick the method by its name, by its action name. But you probably don't want to try and do both those techniques at the same time. Don't have a mixture of routes with action variables in them and routes without, unless you're just being really specific with the action-based dispatch ones. OK, so we've picked an action. Now we need to actually provide the data into those parameters. And that's done through parameter binding. How does that work? Well, what we'll do is we'll look at the types of the parameters for your action. If they're simple types, like ints, strings, booleans, things that can be easily converted to and from a string, we'll assume that that's a parameter that's going to come from the URI. We'll look for that value by name in your query parameters or in your route data. If the parameter is a complex type, like customer, order, then we assume that data is going to come from the body. And there can only be one thing that comes from the body, because what we're going to do is we're going to use the configured set of media type formatters, or formatters, to deserialize the data in the request and populate that object. Media type formatter is a component that can handle a particular content type and produce an object out of it. And it also has the ability to go the other direction. It can take an object and format out that object in that particular content type. And they're symmetric. You can use them on the client or on the server. We provide you media type formatters out of the box for XML, for JSON, and for form URL encoded data on the inbound path when we're reading the data. We don't support writing form URL encoded data because that's not usually what you're doing with form URL encoded data on the wire. Those formatters will plug in automatically into HTTP content negotiation. So we'll look at the content type, and we'll pick the right one. Now, what if you have some value, though, that you need to change that convention? Like you have a string that's coming in the body. You can use the from URL or from body attributes to change that default. Like if you have a complex type, like a location, it has an X and a Y, and you want the X and the Y to come in the query parameters, you can do that. You just need to tell us that this complex value is actually going to come from the URI. So apply the from URI attribute. You can also do MVC-style model binding to do, as a way of doing parameter binding, and you can just apply the model binder attribute to make that happen. You can also define your own custom parameter binding by just plugging into the system and saying explicitly how you want parameters to be bound for your action. And lastly, you can always just work directly with the HTTP request message. The HTTP request message is right there. It's available to you. You can look at its headers. You can pull the data out of its content. The parameter binding is just there to make your life easier, but you can always drop down to the request message itself. As the data comes in and we bind it to the parameters, we also validate the data. Validation is run on all the bound parameters, and you specify what your validation rules are using the data annotations, like bracket required or string length to say how long the string should be. And we'll look at those annotations on your types, and we'll run validation logic and accumulate all the errors that we find in the model state, very similar to the way MVC does. So if you're using validation, if you're relying on it, in your actions, you're going to want to, either in your actions or in a cross-cutting way, you're going to want to make sure that the model state is valid. And you do that just by checking model state is valid. And you have the option of also sending back all of the model state, the validation errors back down to the client. We provide a really simple way for you to do that. You can just take the request, and ask for an error response to be created based off of the model state, as shown there. Okay, so that's how parameter binding occurs. We now have data for all the parameters. We invoke your action. You run your wonderful business logic, do whatever it is you wanted to do, and you return us something, some object, and we're going to now format the response. The returned object is serialized into the response using, again, the configured set of formatters, except this time when we're picking the formatter, we're going to do it based off of content negotiation. And that basically means the client's going to send you, has the option of sending you an accept header that says, if you have it, I'd really like this data in JSON. Or I'd really like this data in XML. Or I'd really like it preferably in JSON, but if not that, then XML. And you can say very complicated things in this header. ASP.NET Web API will just take care of that for you and pick the right formatter based off of the ones you've got configured. Again, you don't have to do that. You can always just return directly HTTP response message and format the response yourself. And you can also set the headers yourself by dealing with the HTTP response message. Okay, so let's do it. Let's do some more interesting web API than that values controller that we started out with. Okay, so here's what I'm going to do. I'm going to define a new model type, some piece of data. Let me add a new class here. Let's call it a to-do. Okay, and I'm going to use any framework code first. I'm going to use the entity framework code first convention. So let's have an int, to-do ID, and then let's give it some sort of like title, something that describes what it is, and is done, right? It's got to, you do to-do, so we should have a boolean here. Okay, build. So I want to create a web API that lets me manage a list of to-do items. That's the idea. All right, so I want to create a web API. It means I need to create an API controller. Well, to do that, I could start creating the class and writing the actions manually myself, but we provide you a little bit more help than that. You can do add new controller, very similar to how you could do with MVC. And this is going to bring up the add controller dialog. Let's call this a to-do controller. And in the templates that are available, you'll notice that there's this API controller with read-write actions using Entity Framework template. And that's just available to you out of the box, so I'm going to select that. Let me pick my to-do model type. I don't have a data context made yet using Entity Framework code first, so I'm just going to create a new one. Let's call it to-do context. Okay, and add. And this is going to scaffold out for me some code that will provide CRUD operations, get, post, put, delete, over a set of to-do items. So let me collapse this so you can see the code. Okay, so I got a to-do controller. So I would expect the URI of this resource to be API/to-do. And then I've got, I can get the list. I love this, the to-does. Isn't that awesome? Is that right? To-do, to-dos, to-dos? Anyway, so I can get all the to-do items. I can get an individual to-do item. I can update them. I can post them. I can delete them. And then there's a disposing logic for managing the to-do context. There's my Entity Framework data context. All right. So let's look at some of these implementations. I mean, getting all the to-dos, that's really simple. It's just going to get the to-dos. For getting an individual to-do, it's doing a find by ID. Now, this is a little bit interesting. This action is returning a to-do like you would expect, but there's some error conditions that you need to be able to handle here. Like maybe that item doesn't actually exist, and so you want to return an actual HTTP error response with a real error code. There's two ways I could do that. I could just return an HTTP response message and set the right status code and do whatever I want in that response message. That would mean I'd have to change my signature. This is a convenient way to sort of shortcut your logic and say, I need to send this response right now. This is what it is. And you do it by, you can throw a new HTTP response exception, and you just provide the response message that you want to send. So in this case, I'm just sending back the scaffolded code is sending back a not found error response. You'll notice that the API controller base type gives me the HTTP request message. It's available as a property. If I wanted to actually parameter bind to HTTP request message and have it be method signature based, that works too. You can parameter bind to HTTP request message directly. So you can have an action. It just takes the request and returns the response and then do whatever you want. All right, let's look at some of these other cases. So post is actually returning a response message because it has a bunch of different kinds of responses that it might want to do. You'll notice that post is checking is validating the incoming data. So if I had required attributes or string length attributes on my to-do model type, those would be honored and errors would be aggregated in the model state. You notice that if it's not valid, then I'm returning a response. This scaffolded code is a little bit old, that's sort of the old school way of doing it. In the new world, you can just do this, like I showed you previously. If I can spell, thank you. And then that's one that takes an exception, that can control the entire payload, and there's model state. So this will actually I've now updated my code, and this is the way you're supposed to work with scaffolded code. It's a sort of a starting place. Then you just go in and hack away and do whatever you need to do. So this will now return me an error response that actually has the model state validation error serialized into it, and it will honor full content negotiation. It'll give you it as JSON, as XML, or whatever you've got configured. All right. Now, when you're so that's in post semantics basically means create a new one usually. Like create a new resource, and if you can, please let me know where you created it. I'd like to know the address. And the way that's done is through a location header. So you'll notice here, when the scaffolded code creates the response, it uses a different status code than just 200 OK, I did it. It says created, 201 created. I created a new resource. And not only that, in the response, it's populating a location header to say this is the location of where that resource was created. And it's using this URL helper that's available on the base type. It's very similar to MVC. This is a way for me to kind of run routing in reverse to generate links. So I can say, and here's a link to the newly created to-do resource. Now notice, this is the new HTTP programming model. So I've got strongly typed access to headers, strongly typed access to status code. This location is not just some random string I have to type in a string key in order to figure out what it is. I actually have a URI, strongly typed location header. It's pretty nice. Okay. And that, let's see, we talked about validation, formatting. So let's run it. All right. So now I'll go back to my help page. Let's see what happened. All right. So there's my new to-do web API. It just shows right up because you add another controller, we find it. I can get to-dos. Let's look at the format of the sample objects. So yeah, it has a to-do ID, a title is done. So we recognize the types of your actions. I can see in XML, I can see it in JSON. This is a real convenient place for people who are like third-party developers that now want to use your web API. Like if you want to open it up to other client developers, they can use this documentation to get up and running pretty quickly. The help page code, actually, I'll mention, it's not like it's some opaque assembly that's buried someplace and you're stuck with this styling and you can't touch it. We actually just give you the code. This is just a standard MVC view. If you want to know where that help page is, it's just right here in this area. And all the views are right here. If you want to change how that help page looks, if you want to add custom code, you want to add your own styles, you can go ahead. We just give you a starting place for you to create the help page that you want. Okay. That looks great. So there's a real web API with actual backing in data. I think that should do. Let's move on. Okay. I didn't talk about the gray boxes. What are those gray boxes? These are filters. I mentioned earlier that web API gives you a way to deal with cross-cutting concerns. Things that ideally you'd rather not live right in your business logic. If you don't want to do check model state is valid right in your actions. I mean, that's something that has to be done in every action. Can I just pull that out in some way? Well, the answer is yes, absolutely you can. And the way you do that is using filters. And there's 3 kinds of filters. The first is action filters. And action filters basically run just before and just after the action execution. So you could write a require validation action filter that checks the model state is valid, handles sending back error responses, and not have any of that code actually live within your action implementations. The second kind of filters are authorization filters. And if you're familiar with MVC, these concepts should seem similar. These are different filters than the MVC ones, and some people get tripped up by that. The reason why they're different is because they don't have a dependency on system web. They're using the new HTTP programming model, not the old intrinsic. So that's why we have two different filter models, but they should feel really similar and they operate in the same way. Authorization filters run earlier in the pipeline. They run before even parameter binding has occurred. So that's a great place to stick your authorization logic. Like you don't want to let someone in unless they have the right access token or something like that. We provide an authorization filter for you out of the box, the bracket authorize attribute. You can require that there be some sort of principal on the thread or that principal be within a specific role. And lastly, there's exception filters. And exception filters run at the very end. If there's an exception that's occurred and no one's handled it and turned it into a response message yet, that's sort of like your finally block, your last chance to take that exception and turn it into a real useful HTTP response message with a real error code. Otherwise, you're just going to get a vanilla 500 error. Filters can be configured globally for the whole app. They can be configured per controller, and they can be configured per action. An interesting filter that we provide for you out of the box, well, that's new in the fall 2012 preview, is support for query. ASP.NET Web API is building out support for full OData support, actually. And OData has a query syntax for the URI, and we are supporting this syntax. If you've followed ASP.NET Web API in the past, we've had this support we had it in previews, and then kind of went away for the RTM. It's back now, and the reason why it's back is because it's now built directly on OData lib, the stuff that the Microsoft OData team is putting out. And they are actually building out a full query parser for us so that we can provide rich query semantics on top of ASP.NET Web API. So query, that's a cross-cutting concern, right? I've got a collection of stuff. I'd like you to be able to slice and dice it in different ways, filter it, order it. I could have a bunch of actions that handle that logic in each of the actions, but wouldn't it be nice if you could just have a queryable component that you could just slap on your actions or on a controller and say, make these things queryable. So that's what we provide for you. We also, while we're talking about query, I'll also mention that we have a new feature here as well where we actually support parameter binding to what's a type called OData query options. And that is just a parsed representation of the OData query. So instead of letting an action filter handle query for you, you have the option of just saying, give me the query and parse it for me so that I can deal with it. But don't run it for me, because maybe you don't even have an iQueryable implementation to run the query against. You can use the OData query options to apply the query to iQueryable if you have one, but you also have the option of saying, actually, let me know what the filter is, let me know what the order by is, and then I'll create my own queries. I'll decide if I'm even able to support this query. And maybe you produce a little bit of SQL, or maybe you call some other backend web API, or whatever your query backend story is. You have that option with the OData query options. And then paging is once you've queried the data, I'd like not to just send it all back. I'd like to only give you pieces at a time and have a way for the client to ask for the next bunch. And OData gives us that. So let's see how we can do that with ASP.NET Web API. OK. So what I'm going to do, I've still got my to-do controller. I can get a list of to-dos. And what I'm going to do is I'm going to add queryable to the get to-dos action. This is the thing that gives me all the list of to-dos. OK? So let's run this. And I'm going to need to be able to create some to-dos. So to do that, I don't have a client right now. So let me pop up my favorite dev client, Fiddler. If you're not familiar with Fiddler, Fiddler is a fantastic tool for dealing with HTTP. Highly recommend it. OK. Let's turn on capturing. So I need to add some to-dos first so I can actually query for them. So let's do a post. And I'm going to do content type application / JSON. So I'm going to send some JSON data. And whoops. I want to send it to API to do, right? What does it look like? I don't know. Well, maybe I can use my help page to help me do that. So I'm going to do a post there. There's a little sample. Let's use that. So I'm going to copy that, post it right in here. All right, so to do one, sample string 2, sure, that looks great. So let's execute that. Let's do sample string 3. Let's do one that's like false. I'm not seeing these coming back. There they go. So you see that those last 2 requests succeeded. I got a 201 created. Let's look at the one of them. So this was a 201 created response. That means it created a new resource. And then if I look down here in the headers, you'll see the location for that created resource. Let me copy the header value. And actually, while I'm at it, I'll just go back in here and do a GET request just to make sure it's really there. So GET. Is there really a new to-do item there? 200, OK. Yeah, OK, there it is. Sample string 2. That was the one I originally sent. OK, so let me add a couple more. I'm going to replay this in the composer. There, OK. So I did 3, 4. Let's make this one false. OK, so I should now have a bunch of to-dos. Let's get them all. See what they look like. OK, so I've got 3 to-dos, right? So sample string 3, 2, 4. A couple of them are done. One of them isn't, right? So let's now do some querying. So that was all of them. We'll type some OData syntax here. So let's say I only want, like the top 2 this time. Don't give me all 3. Just give me 2. So there's only 2. OK. Let's and order by equals title. Let's order them by their titles. So 2, 3. That's in the right order. Okay. Let's do a filter where is done. Oh, Fiddler unfortunately wants me to type in URI encoded format. So %20 is a space. Okay. Equals. So a little equal operator in OData. Let's see, true. Oh, what did I do? Filter. Like that. Oh. Let's see, where's the response? Query specified is not valid. Does not have a property true. So I must have typed my thing wrong. Filter. Sorry, what? What am I doing wrong here? Is done. I don't think so. There's not a space there. Why does it think that the true is the filter? %20, %20. I don't know. Let me try this in the browser just real fast. Sorry, 1 second. Sure. I think I probably got an error response again. Apparently, I don't remember how to type filters. No, it shouldn't. It's filter. I don't know what I did. I changed the big T to little t. I guess that big T is not supported. But there, you'll notice that the to-do items that are coming back are actually true. Sorry for my lack of typing ability. So it needs to be a little t. All right, so that's filter, order by, top, skip. We support the any and all operators now as well. And we just continue to build on it. We don't currently support expand and select, but where those will be coming in the months ahead. So that's query. Yes, you have to return a enumerable of something. The programming model is either return an iQueryable or an iEnumerable of stuff, and we'll run the query over that thing. Okay? The question was, is there any performance difference between iQueryable and IEnumerable? So basically with IEnumerable, we're going to turn it into an iQueryable for you. So I believe at that point, basically, you're doing link to objects. If you return an iQueryable, which is actually like entity framework data context stuff, then you're going to get a real query provider, and the queries run against that thing are going to go back against the database and come all the way back. So yeah, it makes a big difference what your query provider is in this case. And that's assuming you have one. If you don't have one, the other option, if you don't have a query, full iQueryable implementation, and you don't want to use link to objects, you can instead just model bind to OData query options like this. Okay? And then if I run that, let me run this time with a lowercase t, right? So here I have a filter in the query. And let's say I don't actually have a full iQueryable implementation. And I don't really support all filters. I only support very simple filters over my backend data store. What did I do wrong? Did I forget my breakpoint? Let me have my breakpoint. Okay. Lowercase t. Okay, now I'm in my action. And let's look at this OData query option. So I'm not using bracket queryable in this case. In this case, I'm saying, let me handle the query. So with this OData query options, I do have the ability to apply the query to the return result. If you look at the, let me see, let's do like OData query dot apply to. So this method takes an iQueryable, and you can say, please convert the query to a link expression for me and apply it to the query. You can do that. I also have the option of just looking at the query myself and deciding what I want to do for it. So for example, here's the filter property, and this is the fully parsed filter. I can see the raw value, is done equals true, but I also get the query nodes. I can traverse the abstract syntax tree for that query and decide what I want to do with it. I can apply some pattern matching and say, this is a query that I don't know how to deal with, so I'm not going to handle that. And then you can convert that query into whatever query format makes sense for your system. Like maybe you're going to run the query against a backend system using SQL or what have you. So that's a convenient way to deal with query as well. That's new in the fall 2012 preview. So the apply to will convert the parse syntax tree for the OData query into a link expression that can then be applied to the iQueryable. The syntax tree that you're getting, the nodes are actually a data model that's provided by OData lib. That's part of their new URI parsing logic that they're shipping in OData lib. All right. Last thing I'll show is let me put back my queryable action filter. And this time, I don't want to return all the results. I only want to return some. So let's say result limit equals 2. Okay. Let me F5 that. Okay. So let's do a get this time. And you notice I only get 2 responses. There's 3 to-dos in the database, but I've only got 2. That's because we applied the result limit. Well, that's cool, but what about the other ones? How do I get the rest? Wouldn't it be nice if there was a way to get next links? Well, OData format provides that for you, but I don't have an OData formatter configured. We're actually providing you one now. Let me go ahead and add it. So let me stop. And the way, actually, in the interest of time, since I was moving. Well, okay, we'll do it. So if I go to my web API config, I want to add a new OData formatter to my configuration. So let's do config.formatters.add. I want to add a new OData media type formatter. And this is going to add support for the OData atom feed syntax, the OData JSON syntax. JSON Lite is not in yet in our bits, but it is coming. So there. Now this is going to require that I hand it an EDM model. So I need to build one for my Web API in this case. And now Web API in general doesn't enforce any particular resource model. But now that I'm doing OData, I need to provide one. So let's build up an EDM model. It's really easy to do, actually, because we provide you a convention-based builder. So I'm going to do IEDM model, get model. And then I'm going to use the OData convention model builder. Did I get that right? Yep. Builder. There it is. And then I'm just going to add an entity set for my to-do type. Okay? And let's call the entity set name to-do. And what this is going to enable is a generation of next links and enable the format. I need to resolve the namespace. And then let's do get model. Thank you. I'll return something. So return builder.get EDM model. How about that? Okay. Needs to be a static method. So now when I go into Fiddler and I ask for the to-do items, I'm going to use content negotiation. I'm going to add an accept header. And I'm going to say here, I accept application / Atom plus XML. Okay, I'm going to basically request OData. Am I up? Okay, I'm good. Let's do that. Execute. Oh, what did I do wrong? Oh, yeah, right. So now I need a bunch of routes. Shoot. Well, we're at time. So in the interest of time, trust me, that would then generate atom feeds. Shoot. Sorry about that. I messed up that demo by accident. Okay. We'll be going back. Okay. So stuff that is coming in OData, and this is preview. You get support for CRUD operations, query. The Atom and JSON formats does work. You just have to go in and add the routes so that they match the OData conventions. OData actions are supported in this preview. We have the model builder, a convention-based one, or you can go in and explicitly do what you want. We do support $metadata. We support inheritance, and we support collection properties. There's a bunch of things that we still don't support yet. Select, expand, containment functions, and so forth. Features that you may be familiar with WCF data services. But we are working through those, and they're coming. And you can follow our development on in our Coplex site, on ASP.NET webstack.coplex.com. If you're trying to decide, well, which should I use? Should I use WCF data services, or should I use ASP.NET? The way you should think about it is, well, WCF data services is going to give you a great turnkey solution over a database. If you have a database and you just want to expose it as an OData endpoint, go ahead and use WCF data services. It will work great. Where ASP.NET Web API OData support can give you some value is where you have a custom backend data store that doesn't support full iQueryable. It could be a bunch of web APIs. It could be, we've talked with people who have like custom database implementations. And you can do those things with WCF data services, but you end up having to implement their provider model, and it can get complicated. Whereas with Web API, you just implement some actions, and then you deal with your data source however you want. You can also support just as much query as you want with Web API. Like I showed you with the OData query options, we'll let you parse the query, and then you decide how much query you're going to do. Whereas WCF Data Services requires iQueryable, and it will do all sorts of interesting and fantastic queries. Very, very powerful query engine. With Web API, you can constrain it more and say, I just do these queries. It's also a lot easier to put whatever business logic you want using ASP.NET Web API. WCF Data Services does have a interceptor pattern, but with Web API, you get the full context of the request. You can implement whatever business logic you need. So that's the way to sort of think about it. All right. For hosting, we have Web API has a full HTTP pipeline. This is the symmetric client and service pipeline that I mentioned before. On the client, you have HTTP client, and the request and response message, HTTP request message, and HTTP response message. And then there's a pipeline of message handlers. The message handlers are, as you see here, they're just a simple abstraction where you can send the request and you return a task of HTTP response message. And the whole pipeline is just built on these message handlers, a chain of these message handlers. There's a special one on the client that knows how to put the request on the wire and receive the response. That's the HTTP client handler. It is itself just a message handler. And then when it gets to Web API on the server, we have a HTTP server implementation that some hosting layer deals with getting an HTTP request message off the wire and then hands it to our server, and it flows up. The last message handler in our pipeline is our dispatcher. And that was that boxes and arrows diagram you saw previously, where we pick a controller, we pick an action, we parameter bind, call it, and it comes back down. But they're all just message handlers. So you can actually take our HTTP server and hand it right to HTTP client and run the whole pipeline end-to-end directly in memory. We have also written a little hosting layer. We've written the hosting layer, obviously, for ASP.NET and for IIS. We also wrote a simple one that just has a little tiny, basically, HTTP listener at the bottom so that you can host web APIs in any process. Just show you that fast. Here is a self-host server program. This is just a console app. And here's my web API controller. No, sorry. Thank you. So here's my web API controller. It's a hello controller, and it just has a single get action that returns hello world. And then in my main function, I set up a base address, and I set up a config, just like you saw in the MVC project templates. It looks very much the same. The only difference is that now I'm providing the base address. But I'm just setting up a routes. So this is like ASP.NET routing running outside of ASP.NET, which is pretty awesome. Then I have this self-host server, which is an HTTP server implementation that has that little layer of HTTP listener at the bottom. But it's the same dispatcher at the top. I open it up, and then I'm using HTTP client to make a GET request to that, the API/hello to get hello world. So if I run this, I would expect to see there's the server open, and I get hello world back. If you don't believe me, let's actually hit it in the browser. What's my address? I don't remember what it was. It was 52123. Localhost : 52123 /API/hello. And there it is. So that is a full web API running in your own process. You could run it in a worker role if you wanted. You can write your own host if you want. Instead of using our little HTTP listener layer, maybe you want to stack web API on top of a completely different web server. That's perfectly fine. Okay, so great. So now I know how to build web APIs. I know how to host them. I know how to use them. What about the multiple clients? How do I do multiple clients? Well, let's do 3 clients really fast. I apologize for being a little over time. Let's do a web client. So I had a to-do application. I want to do a web client for a to-do application. It lets me manage a list of to-dos. Great, I need to write a bunch of HTML5 and JavaScript. Maybe I'll use like a single-page application model where I do a bunch of jQuery and pull down the data from my web APIs. Sounds awesome. I'm not going to implement that in front of you because we actually provide a template that shows you how to do that right out of the box. Like if I go back to Visual Studio. Yep. Thank you. Okay, file new project. If I go back to web, MVC4, if you were sharp-eyed, before you would have noticed there's this single-page application project template. And that's going to give me a full to-do app with a rich HTML5 and JavaScript-based browser application. And it's backed by a web API. I'm not going to do that in this case because I've already got one. Where did it go? So build demo, solution explorer. Where's my solution? File. Oh, crap. File. Okay, so I've already did that. This is just the standard SPA template, and it is just basically knockout.js on the client. But on the back end, if I look in here, there's some web API controllers. There's a to-do controller. This also manages multiple lists of to-dos, so it has a to-do list controller. And on the client, it's just using jQuery to pull down the data. And I've already pushed this up to Azure websites. So I'm going to browse to http:// build to do azurewebsites.net. please. Okay, so here it is. This is what it looks like, and it says I can log in. And so here's there. You saw that there's a little delay actually, because it's not sending the data down initially with that HTML view. It was actually pulling it down over jQuery. You want to see it again? Let's do enable capturing, Control F5. Yeah, so you see down here, this is API/to-do list. And there, if I look at the response by, that's the JSON that actually came back from the web API. Okay? And I've got some pretty UI here. If I click things, I can add a new to-do list and expands, and that also closes. That's all the rich client in the browser experience. This supports the third-party auth providers logins that we've shipped with MVC4. So if I, instead of logging in with forms auth, if I want to log in with my Facebook account, this bounced me over to Facebook, and it bounces me back, and that's all done using OAuth 2. So again, I had an account associated with my Facebook account. So that's all nice. So great. This is one client. It's a browser client hitting a back-end web API. What about the other clients? Like I want to support like a Windows Store application or maybe a Windows Phone application. Can I do those too? The answer is yes. Let's see an example. And again, this is just HTTP, so as long as I can do HTTP, then I'm able to create a client app that targets that same back-end business logic. If I go back to my project, you'll see in this project I have two additional projects. I have a Windows Store project, and I'll show you the client code really fast. Here's my data source. Okay, so in here, let's find the web API call. So I'm using that fantastic new HTTP client. I'm setting up a request message for my HTTP client, and I'm just making a GET request to API/to-do list. Now, security is a bit interesting in this scenario because the browser was using forms auth, right? It did a form post, and it got a cookie back, and that's how security was being managed. Using form posts and cookies from a Windows Store application, from C#, not the most ideal situation. So what I did here is actually next to the web API, in the single page application, I also implemented a OAuth 2 authorization server. And I did that using .NET OpenAuth, which is a third-party library that we ship with MVC4. So I'll show that real fast. So you'll notice that in addition to my to-do controllers, I have this OAuth controller. And if I reduce, it's basically got two actions on it, an authorize action and a get a token action. So the scenario here is that my Windows Store app or my Windows Phone app is acting like an OAuth 2 client. It's another app, and as I own the resources on the to-do app. These are my to-dos, but there's this client app, a Windows Store app or a Windows Phone app that wants to access my to-do items. And so what OAuth 2 does is it gives me a way to authorize a client app to access my protected resources, ideally without me even having to give it my credentials. And if I do have to give it my credentials, because I trust it and it's okay for it to use them, at least it doesn't have to hold on to them because it can exchange those credentials or it can exchange my authorization for an access token and then use that access token to access the web API. So on the server side, I actually implemented a message handler. Remember we talked about the message handler chain that uses the .NET OpenAuth, this resource server API, to look to see if there's an access token there. If there's one, it populates a principal for the user on the thread. And so that's how the Store app and the Phone app are able to access the web API in an authenticated way. Now, how do you get the access token from a Windows Store app? Well, Windows 8 shipped this great feature called the Web Authentication Broker, which is basically like a little sandbox browser OAuth 2 client that you can use to pop up a little browser for the user and ask them to authenticate with the authorization server without the Windows Store app ever seeing their credentials. So let's see what that looks like. And then we'll wrap up. Start new instance. Okay, so this is my Windows Store app. And there's the Windows Authentication Broker just popped up. And I pointed it at the authorization server on the web API and in the SPA application. And it's asking me to log in. It looks like the same login page that I had before. It's because it is. So let's say I want to log in with Facebook. Let's go ahead and do that. I had already logged in with Facebook before, so it already had my credentials, and it logged me in, and there I'm able to see my to-dos. These are the same to-dos that you saw on in the browser app. Now with phone, it's a little more difficult because there is no authentication broker there that's available for you. You can play around with popping up browser controls to try and accomplish the same type of functionality. But in this case, there's another pattern where you just trust the app with your credentials, and then the app exchanges your credentials for a token. So that's what I did with the phone. So let's start the phone. So here's a Windows Phone 8 app. In this case, I'm just going to type in not my Facebook credentials, but my form Windows the form credentials. All right, and it's going to do the same thing and pull down the data. If we look in the phone application, instead of using, unfortunately, HP Client is not yet available on phone. We're working on that. Let me show you what that code looks like. So on the phone, I'm just using Web Client, the older HP APIs. But again, it's just same thing. I'm just doing a GET request to pull down the to-do list, and I'm populating an access token that I retrieved from the authorization server. Okay, so there's phone and Windows Store clients with the same backend Web API. So in summary, thank you for sticking around. ASP.Web API is a great framework for building HP services that can reach any client. It works great for building backends for Windows Store applications. You can publish them up to Azure. That was all hosted in Azure, what you saw. It takes 2 seconds to do that publishing. It's really simple. Give it a spin with the new ASP.NET Fall 2012 update. That's where you'll find the new SPA project template. You'll find help page for Web APIs. You'll find OData support. You'll find the tracing support wired up by default. It's pretty cool. Give us your feedback, and I'm happy to stick around for questions. I'll be in the blue brain box, I believe, for anyone who wants to talk to me. Thank you so much for coming.